Hey everyone, Vessel here, and I wanted to go over the answers to changing and transforming data. So in this particular video, you'll notice the answers are already going to be there, and I'll talk about some of the common issues with them, and the themes. So hopefully this will work out pretty well for you. So all I've done in part A here is basically just type in these 9 numbers, and then calculate the statistics. You got your mean and median over here. Your standard deviation, I use the population here because it said to, and then IQR and range are located here as well. So what this really is about, though, is like sort of what happens when you change data around. So like in this part B, if you make the 17 a 73, sort of think about what that does to the data set. But the calculations are kind of the easy part, but kind of making sense of them is really what this is about. So, as you kind of look at the numbers, they're fine. The big difference, is the mean changed by 6 points just from one score being adjusted. Another massive difference is the standard deviation went from almost 21 down to a little bit less than 8. So the spread, and again, standard deviation is the average distance from the mean, or in this case, average quiz score from the mean, and you can tell it went down a lot, and that's really because of what's coming up next. But standard deviation can be heavily impacted by a single number. So before, this number 17 was very far away from average, but now if that's a 73, it's no longer that far from average. So that's why you see this big adjustment here. Your IQR changed 4 points here, a little bit, not drastically, but it changed a little bit. And then the range changed a lot too, because you change the minimum, make that a lot different. That's going to change your range. But in general, C and D is really what this question's about, and outliers have an impact on specific statistics more than others. So that's what this is getting at, is like this idea of robust. That's a vocab term in statistics. It means it's resistant to outliers. So these two particular statistics, median and IQR, typically not impacted by removal of outliers. And think about how those numbers are calculated. That might make sense, especially with large data sets. Your mean or median and IQR really won't change much at all, if at all, when you have large data sets and you just take out a couple outliers. So in this particular case, median didn't change at all. The IQR did change, and it did because this is a relatively small data set. If you take a large data set, maybe you had 100 quiz scores, and you throw out a couple outliers or change them, your IQR won't change much because the IQR is based off of Q1 and Q3. So median, Q1 and Q3, these numbers don't change much based off of a single outlier because they're not measured with an outlier. They're just measured by what order they are in the data set. So those don't change very often. Numbers that do change a lot, called non-robust. That's your mean, standard deviation, and range. And these can change very drastically just from one outlier, and that sort of happened in this case too. Mean changes a lot, and again, it's because how you calculate a mean is by adding up all your values and dividing by the total number. So getting rid of that outlier can make a very big difference. Similarly with standard deviation, is a measure of spread. That's going to drastically change your number because of the fact that the new data set has less spread if you throw out outliers. And similarly, max and mins get thrown out, you're going to change your range quite a bit. So that's kind of the purpose of the front page, is to see kind of what happens with an outlier. And on the next set of tasks, number 2 and 3, are working with that same quiz data set. And what I've got here is notated it as like Q for quiz plus 3. So I'm sort of indicating I'm adding 3 points to all the quiz scores. So I've done that, and then I found my new measures. And really the important part is what happened was that the mean and median, those increased by exactly 3 points. That might make sense. If I add 3 to everything, my mean of course goes up by 3. And the median does as well, because, well, if it was 80, now that number's just been shifted up to 83. That's still the middle number. Just as important, and maybe makes sense just as much too, this number, Q3, or the standard deviation of quizzes plus 3, the IQR and the range, they're actually the same as what they were before. And hopefully that makes sense too, because if I add 3 to everything, sort of look at it this way. If I have these numbers and they're kind of between my left and right hand, and I just move them up 3, the spreads are all the same. So your standard deviation, your IQR, and your range, those don't move. And that's kind of what I've indicated down here in purple and green. And then the next step is to not next step, a different step might be to quiz these, or curve these scores by multiplying it by 10. So write down the new data set, Q of times 10. So this one changed the new mean. The mean is 724.4 repeating. The median was 800. The standard deviation 209.9. IQR is 165, and the range is 750. And what happened in this case, if I multiply all my data points by 10, of course the mean gets a lot larger. It turns out it got 10 times bigger than what it used to be. The median got 10 times bigger. The spread also gets bigger in this case. So the range, the IQR, and the standard deviation were all 10 times larger than what they were before. And you see the numbers here from 2A and also from 1B. They're the same, or 1A, I mean. They're the same, but when you multiply by 10, it changes those by a factor of 10. So all measures were 10 times larger. Next was number 4, where this had a set of summary statistics, a sample of 100 people, and you get this data set in inches. It says describe how each of the summary statistics would change if we moved to feet. Well, just a conversion between inches and feet is just that there's 12 inches in a foot. So if I wanted to convert these, I would have to divide all the inches by 12. And if we did that, basically what would happen is that every measure would be reduced by a factor of 12. So I've listed them up here. It's not required to get the actual numbers, but 70.2 inches is the same thing as 5.85 feet. So it's divided by 12, and so on and so forth. All of them have been divided by 12. With part B, describe how each of the summary statistics would change if there was an error and every data point was entered 2 inches more than what it should have been. So in this case, that's a little bit different of a scenario. If I had these 100 people and they were all entered incorrectly, where they were 2 inches more than what they were supposed to, if I took away those 2 inches, what would happen would be that the mean, the Q1, and the Q3 would all decrease by 2, but these two numbers wouldn't change. The same reason as before. The standard deviation being 6.3 inches, subtracting 2 inches from every single person won't change that average spread. So the measures of spread here, these two values, wouldn't change at all. Range would still be 38. Standard deviation would still be 6.3 inches, but these three statistics would change by just a subtraction of 2. So that's what it says here. And then the last page that you were doing on your own, number 5, was about the kicker. And with this context, it is data from a kicker where, in a football game, if the ball is snapped from the 17, the kick is made or missed or whatever. But this data set is where the ball was snapped. And then down here, you're finding the mean, median, range, and IQR. So you got these 4 statistics to find. So I've got those listed here, and then identify any outliers. If you want to check out how I calculate outliers, you can check that out in a different video. But 3 and 35 are outliers by the 1.5 IQR method. So you got an outlier here and one over here. So you got one on each end. On part B, so this was an adjustment to the data set. So the distance of a field goal typically is not measured from where you snap the ball, like the 3-yard line, for example. Instead, it's typically measured from the field goal, the yard line, but you add 7 yards because that's how far the snap goes back to the holder, and then 10 more yards because the field goal post is actually in the back of the end zone, and that is an additional 10 yards. So in order to do part B, you correct this data set just by adding 17 to every number, and then you're reporting out new statistics. And by this point, I hope that you didn't actually need to type these numbers in and calculate them. What you should be able to do is just sort of look at your statistics and just see what would change and what wouldn't change. So your measures of center, 18.54 and 18, they're going to go up by 17 yards. The range and IQR are not going to change. Oh, that's funny. Still going to be 32 and 6, and it's because Q1 and Q3, yes, they go up by 17, but since they both go up the same amount, when I subtract those two numbers, there's still going to be a difference of 6. And now the outliers are still the same 2 data points, still 3 and 35, but I do have to add 17 yards to those, so it's 20 and 52 now instead of 3 and 35. But they are going to be the exact same outliers. And then down here in part C, this is just getting rid of those 2 outliers and then sort of seeing how the data adjusts. And because there was one on each side, you're going to see like the mean doesn't change too much. And if I take a high number and a low number, they kind of balance out. So you'll notice the mean and the median doesn't change at all, because if I take one from each side, I'm still going to have the same center point. And the mean changed a little bit, but is really by like 1/10 of a yard. So removing a data point on each side doesn't change it much. Now the 2 that do change quite a bit because of the removal on each side was the range was one that changed quite a bit, and so was the IQR moved just 2 yards, so it didn't move a lot, but it moved a little bit, just changing those last 2 data points. And with part D, basically it was supposed to say 5C here, not 4C. So using the data set from part C, what would happen if I changed everything to feet? So, if you multiply, if you change yards to feet, there's 3 foot in a yard. So you just multiply all the data by 3, that's going to change your mean, your median, your range, and your IQR. So all 4 of those statistics just get tripled, and you don't have to, again, make a new list and type them into the calculator or put them into a Google Sheet. We just know from using some of the facts we've seen already that when we multiply everything by 3, it's going to make all your statistics change by a factor of 3. So hopefully this is helpful, and thanks for checking this out, and I'll see you later.